Now let's look at the reverse process, which is writing an equation from given information about a graph. Sometimes we're given the whole graph and sometimes we're just given a couple points on the graph. So let's take a look. Example, in the following figure, the coordinates of point A and B are negative pi over 3, comma, negative 4, and negative pi over 6, comma, 1. We want to determine the equation of this function by first completing some steps. So it says, what would the midline be? Well, I want to label some points here to kind of give me an idea of what this graph is going to look like. So if this is A here, that is negative pi over 3, comma, negative 4. And then it says B is negative pi over 6, comma, 1. Okay, great. So it says determine the equation of the midline. Well, I can see here that the point A is on the midline where y equals negative 4. So the equation of the midline should be y equals negative 4. What about the amplitude? Well, the amplitude, I know, is just the distance to get from the midline up to the either peak or the trough. So how long does it take me to go from negative 4 to 1? Well, the distance between 1 and negative 4, 1 minus negative 4 is 5. So the amplitude is 5. All right, what about the period? Well, this one is a little trickier. So I know that the period is going to be one full cycle. So let's map out one full cycle on the graph I'm given. And okay, so there is in this case, I'm thinking about it as a sine function. And I am given that, in terms of horizontal, I care about the x coordinates that are given. Okay, so I'm given negative pi over 3 for that x coordinate, and then negative pi over 6 here. So I want to know, what is this distance in between these 2 points? And by distance, I'm really talking about the horizontal distance, aren't I? Because if I know that, then I know the period is 4 times that, because I'd have that piece, this piece, this piece, and then this piece. So in order to do that, I'm going to say, what is negative pi over 6 minus negative pi over 3? I say, well, that's negative pi over 6 plus pi over 3. Whoa, that's a wild 3. Which is negative pi over 6 plus 2 pi over 6, just converting this into 6, which just gives me pi over 6. Okay, so I know that the distance between point A and B, horizontal distance, I should say, is pi over 6. So 4 times that should get me the length of the period. So my period is going to be pi over 6 times 4, which is 4 pi over 6, which is 2 pi over 3. Now I want to write the function as a transformation of y equals sine of x. And in these cases, we're going to try to write it as like the simplest version of one of these equations. So what do we get here? Well, the amplitude is 5. I'll put a 5 there. Then I have sine. Okay. I know that I want to write it in this kind of form where we have like x inside there. Okay, and then the midline is minus 4, so just minus 4 out here. What do I want right here? I need this b value right here. Okay, well, let's see. I know that 2 pi over b gives me the period. This period is 2 pi over 3. Well, I can kind of see that this is going to be b equals 3 just from this equation. I can certainly solve it for b. I can do cross multiplication. So I'd get 2 pi times 3 equals b times 2 pi. So I would get 2 pi times 3 equals 2 pi times b. In this case, divide out by 2 pi on both sides gives me b is 3. So here's 3, right? I'm trying to solve for that coefficient, but all I have is the period. So again, what I do is I take 2 pi over that coefficient b is going to give me the period, right? This is the period here. So I can use that equation and then just solve it for the b. Okay, now in this form, I want to think, how is this thing shifted? Well, where does pi normally start? Well, we like to, or was it pi? Where does sine normally start? Well, we like to think of it starting at x equals 0, right? That's where we usually draw like our first cycle. But where is our hill starting? Our hill is starting backwards at negative pi over 3. So I have to shift it to the left. So plus pi over 3 in here, because again, this represents a shift left of pi over 3 units. Now, could I also write this as a cosine function? I can. Notice that a lot of the pieces are going to be the same. I'm still going to have the amplitude of 5. I'm going to have my cosine. The inside here, I still have the same period, 3. The shift is going to be different, minus 4. So really, you're writing the same thing, but just the shift is going to be different. I'll show you how. Go up, back up here. Now, I want to think of the cosine as a bowl. Okay, draw the bowl in. Here's my bowl. Where does the bowl start on this graph? Negative pi over 6. Where does it normally start? At x equals 0. So if normally my cosine starts at x equals 0, this one's starting back here, right? It's shifted to the left. So I have to add in plus pi over 6 to account for being shifted left pi over 6. Okay, how could I write it as a negative cosine function? Well, I do that same thing, right? Because it's really just the shifting is going to affect kind of which type of function I pick. And then I have this part left to fill in. So I want to think about, just looking from this picture here, what if I wanted to think about an upside down bowl, right? Because that's what would opposite a cosine would look like. So think of it as starting, say, right here. Okay, well, what x value corresponds to this point right here, right? Well, I have to kind of go from my other pieces. If this is negative pi over 3 is a, b is at x equals negative pi over 6, c is going to be at x equals 0 because it jumps pi over 6 each time. So this x value here is going to correspond to just a positive pi over 6. Okay, so if this is starting at x equals pi over 6, but normally, you know, cosine we would think of, or even just opposite of cosine of x would start at x equals 0. And this is right. So I have to write it in kind of backwards. Right actually corresponds to subtraction.